So the best part about when you begin. Oh, just give me a moment, guys. Mm, all right. Hi, Parsa. How are you?
Hi, Mister. How are you?
Apologies about that, Parsa. I completely lost track that you were going to be in the session. Well, I'm extremely sorry about that.
It's
Yes,
fine.
Parsa. So, Parsa, we've not done anything. I've not begun really. Like, but
Okay.
just what we've done is, Parsa, that I just went over the syllabus and we sort of reviewed it. I hope you do have this version of the syllabus, Parsa.
Yeah.
All right. And we're going to be covering paper one first in this session and then mechanics. All
Okay.
right. All right, Parsa. So let's begin. So the very first chapters of your, and apologies to like only Noshin is the one that has not experienced how much perfect my handwriting is. But other than that, that's you, Parsa and Nofal have an idea. So the first chapter in A level math is what we're trying to do is start with quadratics. Now you will notice I've said it time and time again that it is very noticeable that the first few chapters are a direct continuation from your IGCSE. So you've done quadratics before, the name is different over here, and sort of like the syllabus content is a bit different. But apart from that, um, it's very clear to a person who's studying math that there's a direct link between them. Obviously the major difference is going to be in the difficulty level. We're going to try and raise it up. The questions will be different and everything of that sort, but apart from that you will notice that most of the content has been derived from IGCSE. So that is why these first few chapters are extremely easy to do so. Now let's begin off with quadratics. So, first of all, whenever we begin quadratics, what do you guys think? What is your understanding of what quadratic is? Yes. What's the first word that comes to your mind when I say quadratics or when I mention it?
The quadratic formula, basically.
Wow. Well done, Parsa. Yes, excellent. The quadratic formula, basically. And what about Nofal and Noshi? What do you guys think? Yes, Noshi.
The quadratic formulas.
All right. That is absolutely correct. You guys, both of you are spot on. And yes, Nofal, what about you?
Yes, same for me. Expressions in the formula.
Well done. So, wherever you guys are studying it from, wherever you guys are Googling it from, that is perfectly all right because that is what it is. You have your quadratic formula. This is what it entails. So, quadratics is going to be the entire chapter is going to revolve around your quadratic equation and whatever you've derived from that quadratic equation formula as well. So, first of all, like the very basic ideology behind it is that what is quadratics about? And we already know that quadratics is going to be about what there's going to be an equation y is equal to ax squared plus bx plus c. All right. So your entire quadratic chapter is going to revolve around your quadratic equation and how that reacts as well. But before we move on with that, we need to understand a few properties regarding the quadratic equation itself as well. Like what sort of determines the quadratic equation and what is it about? What are the further properties of a quadratic equation? So the first thing that comes to my mind is that the quadratic equation always forms what? It always forms a curve on the graph. That is one property that I know regarding the quadratic equation, that it always forms curves on the graph. Always forms curves on the graph. And mind you, the information that I'm going to be sharing, it's going to sound very monotonous and very repeated, because of the fact that a lot of the information that we're going to cover in the first few stages of these chapters, you guys have already done. So do keep that in mind. So this always forms curves on the graph. Now, what are the orientation of those curves that we need to know as well? Oh, on the graph, apologies. Now, how do we determine what sort of curve it's going to form? Like a curve could be, there could be millions and millions of curves. How do we determine that? Now, usually what happens is that in your syllabus, it's going to form two types of curves. Using the above given general form of the equation as well, we're going to experience two types of curves. What are those? Both of them are going to be dependent on the value of A. And what is A? Let's see. So you need to form this sort of like chain link between all of this. So everything is going to depend on the value of A. And what is A? A is the coefficient of the x squared term. All right. So keep this in mind that A itself is the coefficient of your, this is the same A that we're talking about. Now, you need to know is that if your coefficient of x squared, which is, usually denoted with A, if it's positive,
If it's positive, the parabola opens up, and
if it's
A
negative,
is
it opens
negative,
downward.
and
Perfect, person. Very well.
opens downward. Like it goes
Excellent.
down.
Excellent. So the curve opens up like this. So, kind of like, what my teacher used to give the example was that, when it's positive, we're smiling, when it's negative, we're not. So it's kind of like a frown. So if the value of A is negative, it's going to be, what you may call upside down. The parabola, as Parsa said, is going to be opening downwards. And if the value of A is positive, so this is how you determine the orientation of your graph as well. All right, perfect. Now, this is like the general information we know about quadratics. Now, one more thing we know in general is about quadratics is that we have something known as completing the square. Completing the square. This is just another way of solving a quadratic equation. Just as we use our quadratic formula to go through the, what you may call, to solve the quadratic equation, our completing the square is just another method of doing so as well. Whereas this method, although utilizes the what you may call factorization to solve a quadratic equation, your quadratic formula is rather much more, you can say, straightforward. So that's what it does. So completing the square is just another technique for solving a quadratic equation apart from your quadratic formula, which is much more utilized. What is completing the square? Let's see now. Now, in order to, judge what is completing the square, let's look at the general form of a quadratic equation where you are going to find the values of x. This is the general form of the quadratic equation. All right. Now, what are the few steps? Now, we're going to do this in steps. Let's see what this is. So, for example, what happens is if that this is your, if your quadratic equation, even if it doesn't look like this, even if it doesn't look like this, you need to make sure that your quadratic equation, if it doesn't look like this, you need to make sure in order to convert it to look like this, because then it will be easier for you. Whatever example that you do is going to be, what you may call, um, it's going to be in the, it can be compared to this general formula because this is a much more easier version of it. So the first step that you need to do whenever you're solving an equation, a quadratic equation through the completing the square form, is that you need to make sure that your coefficient of x squared is equal to 1. That's the first condition. Make sure that your coefficient of a needs to be equal to 1. That is the first step. You cannot move this past the first step, like the first detection stage, if it is not equal to 1. Now, for example, let's just say that, in the case of it being equal to 1, let's just say that, whether the quadratic equation, the coefficient of x is like, let's say 2, we we will not progress with completing the square unless and until the coefficient of x squared is equal to 1. So what you will do, you need to get rid of it. And how will you get rid of it? Usually the most usual way of doing it is through factorization. So we're going to factor it out. Maybe take 2 out, maybe take something else, whatever it is. Just make sure at the end of the day that your coefficient of x squared is equal to 1. That's the first step. You cannot move faster. Secondly, what's the second step? This comes along as it is. We're trying to go through with it as it is. Ax squared plus bx. Now what's going to happen? Once you've determined that first step where a is equal to 1, secondly, what you're going to do is that you're going to introduce by yourselves and add actually the half of b, like the coefficient of x, you're going to add by yourself into the equation and you're going to square it. So you need to add this into over here. So what you're doing by yourself into the equation is that you're taking the coefficient of x, which is labeled as b over here, you're dividing it by 2, and you're taking whole square of it, and you're also adding that into the equation. Now, it is very common knowledge that once you're adding something into the equation by yourself, you have to make sure that you're subtracting the same equation, like you have to do the opposite as well. Why? In order to maintain the balance of the equation and in order to make sure that the balance of the equation remains intact. Once you're done with that, the rest is as follows: plus c comes into place. Clear? That's the second step. Now, what happens? I want you guys to simply just look at this. Just staring at this part. Now, you've already obviously done this before as well. But if we look at this part, just this bit, to someone who's obviously done this before, it looks as if this is written as in this form, where we used to do a square plus minus actually plus minus 2ab plus b square. When you do this with an example, it will become more clear. In the general form, it doesn't look that much clear, but technically what's happening over here is that this entire orientation is it's kind of like identical to this orientation, where we used to do the factorization tools and stuff of that sort. So what we're going to do is that we're going to try and solve it like this, where your, because whenever an expression was written like this, a quadratic expression was written like this, we could just simply write it as a plus minus b whole squared. Now the plus minus is written because it depended on the original equation itself, whether or not it was in the original equation you had a plus or a minus. All right, any questions regarding this, Noshin, Parsa, and Nofal? Yes,
No,
Parsa.
sir.
What about you, Noshin? Any questions?
No.
And Nofal? All right. So because this shape of the equation is identical to this shape, and because this can be written as this, can I not write this entire thing as this, where your A is going to be taken as X and your B is going to be taken as B? Like, for example, if the letters are much more confusing, let's replace them. I'll write them down as like this, like X and Y. So you have, if you have X squared to XY plus Y squared, you know, it can be written like this if the A and B are a bit misleading or confusing to you guys. So that is how we used to do factorization before, and we used to write it like this. So now this entire thing, which is identical to this, can be written like this as well, because they are just, alternative forms of each other. Knowing this, I can simply solve this further. Only this guy, I can write it as X plus or minus, whatever it is. Like, for example, and by the way, it can be plus or it can be minus as well, both sides. It depends on the question itself. So what happens is that I can write this as X plus B, and it is going to be what you may call this B over 2 is going to come over here. So it's going to be X plus B over 2 whole square. It's going to come over here. Is this clear? Any issues with this, guys?
No, sir.
All right. And now the question that you guys should have asked is, what happens to the other guy? Like, what happens to the rest of the equation? Like, this part we've completely left out. That you're going to solve accordingly. Like, whatever the constant values are, you're going to just solve them accordingly. So the final sort of outlook of the entire shape is going to be that you can simply write this as, like, the final sort of shape that you're getting of after putting an equation through completing the square is that it's going to be X plus minus B whole squared. And now this entire thing is solved, and it replaces an entirely new, you can say, value of C plus minus C, whatever it is. And I've replaced B over here because, now a new variable can come into play. Like, even you can write it like, if you want to write it with like any other variable as well, I can write it over here, like B, A, whatever it is. So I'm taking this entire thing as now one variable. All right, guys. Do not be confused by this. And X comes as follows, and everything else is just practically the same. Now, that is how you solve an equation using completing the square. I do not believe that this is hard on any level because you guys have done it before. You do have an idea as to how it's going to take place. Clear? Now, how to spot whether or not you have to use completing the square or not? What is going to happen is that if your question says, if your question, usually what happens is that if I write down a sample of a question, it's going to be right in the form, or usually they say express in the form or write in the form, anything of that sort. They say write in the form of, usually they write it like this: ax plus minus b whole square plus minus c. Or there is one other form the examiner tells you to write in, which is like this. And the other form is like, simply directly. Like there's nothing outside as well. Maybe like this. So whenever the examiner tells you to write in these two type of forms, that indirectly means that he's asking you to solve your question using completing the square. So these two versions are very crucial when it comes to understanding what your completing the square is. Is this clear, guys? Any issues at all so far? Partha, Noshin, Nofal?
No.
Sir.
All right. So always remember that whenever you have the whenever you have to write in these two forms, whenever the examiner specifically tells you that you have to mention your answer in these two forms, you know blindly that he's asking for completing the square. So this is his way of just hinting at you using completing the square. So having said that, what is the further representation of using completing the square? Let's look at this because this is how we're supposed to do it. Now, what is the use of writing it as in this form if you can simply, utilize this same way by, what you may call, oops, let me fix my arrow. So what's the use of, writing it in this form if, you can get probably the same answer or even a better or clearer answer using the quadratic formula? The reason for that is that your completing the square form is actually very useful in order to tell us the intercepts of the equation. And by intercepts, I mean the x and the y intercepts of the equation. How so? Let's look at this. For example, if I'm taking this, if I'm taking, the same equation, which is y is equal to x plus minus a. Okay, let's take another example, not the same one. X plus minus a whole squared plus minus c. Now, let's look at the use of this. Your whatever value or whatever constant you have inside the bracket is going to be useful for you in order to tell you the x-intercept. This value is going to tell you the x-intercept of the equation. And obviously the c outside is going to tell me the y-intercept of the equation. How is that going to take place? In order to know that completely, I'm going to cheat. And how will I cheat? Let's see. Just give me a moment. Let's do something fun. By the way, the app I'm using is called Desmos. Kindly do use it as well. If you guys have, access to it, kindly do use it. So let me share my screen again. This is the app itself. This is known as Desmos. Desmos, I think. Yeah. Desmos. Kindly use, also download this app as well because it's going to help us, out a lot. Now I'm going to utilize the same. Just give me a moment, guys. All right. So now let's see how we're going to use this app. So I'm going to write my general equation right down over here, the one that is written over here, this one. And I'm going to see what does that do. So I need to put a bracket. Let's write it with plus first. And I'm going to put a variable here. Okay. bracket closed, square it, and just simply add plus, another bracket, B or C or whatever. Usually, actually, I should write this as in this form. Wait, just a moment, please. Um, this should be written as H, and this should be written as K. And I explain why I'm using these variables as well, H and K. Keeping this in mind, now let's replace them over here as well. Let's put them H over here and plus K over here. Now, what I'm going to do is that, now let's see. Now I've put sliders in. Now we all know that this is a quadratic equation because obviously it's just written in the completing the square form. It is a quadratic equation. If the values of H and K are both 1 and 1, let's just say that, what's going to happen is that this is the, what you may call, your completing the square is actually going to tell you the x-intercept and the y-intercept of your turning point. Technically, if we're putting them down in very technical terms, if I put, actually I should write this as, I think this would become a bit confusing. I should write this as coordinates. So for example, what's going to happen is that this is going to be your x coordinate. I wanted to use the term intercept, as in as they intercept the turning point, but okay, let's see this. So it's going to be the y coordinate of what? They are going to be the y coordinate of the turning point. Both of them are going to be the x and y coordinates of your turning point. What is your turning point? Can anyone tell me what is the turning point?
The stationary point, like basically where
What is the stationary point? Yes.
where if you drew a tangent to that point, its slope would be 0.
Yes. And okay, that's perfect. And it is also referred to as the minimum or the maximum point. Minimum, maximum point. Depends on your graph. So your turning point, your stationary point, your minimum, maximum point is just the same thing. It's kind of like this. I'll tell you. This graph I've drawn, this one, the one that I'm like, sort of vigorously shaking right now, that's your turning point. It is where the graph sort of turns. Now, knowing this, let's look at this over here. My value of H is 1 and my value of K is 1. Now, on your graph, let's look at the turning point. This is my turning point, right? Let me label this as my turning point on my graph. Now, what's going to happen?
So it's basically like the opposite of
The
h
x,
and
yeah,
the same value as k.
yes, perfect. So, what is going to happen is that when you're writing it down in the completing the square form, your H value, the constant which is inside the bracket with X, is turns out to be the X coordinate of your turning point, and your K turns out, or your constant which is outside of the bracket, that turns into your Y coordinate. Now, there's just slightly one catch. You can clearly see in this graph over here, now I'm over here in the Desmos app. You can clearly see in this graph over here that both the values of H and K are 1. But if I look at my turning point, what is the value of my turning point? It's minus 1 and 1. So just as Parsa was telling us, your turning point is slightly, a bit twisted in the sense why that if you're trying to find your turning point using the quadratic or completing the square method, you're going to have to write it down as this. Is, if I want to write my turning point down, it is going to have to be written as negative H and K. So what does that mean? Negative H and K means that whatever the sign you have inside the bracket for your H, the opposite is going to be um, for the x-intercept. Oh, for the x coordinate. All right. So the opposite is going to be for the x coordinate. How so? If h is positive inside the bracket, just as you guys can see over here, h is positive inside the bracket. But if you look at this from over here, in the turning point h, the value of h is negative. All right, Nosheen, is this clear?
Yes.
And Nofal, is this clear? All right. So that is why whatever value of h you have inside the bracket with x, the opposite, the sign is going to be, the only difference is the sign is going to change. So for example, if I use an example, x plus 2 whole squared minus 2. So my turning point is now going to be minus 2 and minus 2. Like you can clearly see, I'll change it. If I put it as minus 2 now, this is minus 2. Now look at my turning point. My turning point is now 2. So whatever is inside the bracket with x, when you write it as the turning point to your, when you write it as the coordinates to your turning point, you're going to have to use the opposite sign. Is this clear? But the issue is not with k. The y coordinate of the turning point is as it is. Whatever value of, what you may call k is there as it is, you'll copy that onto your graph. So for example, if we go into this deeper, what's going to happen is that if it's x plus h inside the bracket, it's going to be minus h outside. And if it's x minus h whole squared inside the bracket, it is going to be positive h outside. All right, when you are going to show it as your turning point. Other than that, it will be written as it is. But if you're going to show it as your turning point on your graph, then obviously you have to use the alternative values. Is this clear? Nosheen, is this clear?
Yes.
No?
Yes.
Nosheen, please be very sure regarding this, okay? I want you to ask again and again if you don't get this.
All right.
All right? Any issues with this? The only difference is, Nosheen, you understood how to get completing the square, right?
Yeah.
Okay, now what has happened is that when you write down completing the square, whatever form it is written in, these two constants, they are actually telling us the coordinates of the turning point. What is the turning point? The point where the graph sort of turns. Clear? And the only difference that is happening is that your graph, your x coordinate is going to behave oppositely. So if it's written plus h inside and they ask you to find out, like, if, for example, if an equation is given to you and they ask you to calculate the turning point, and from that, they ask you to calculate or solve the graph, the equation using completing the square, and they ask you to find out its turning point as well, then you're simply going to look at the h and k constants. One constant is going to be inside the bracket with x, the other is going to be outside, and both of them are going to be telling you what? One is going to be telling you the y coordinate of the turning point, and one is going to be telling you the x coordinate of the turning point. Is this clear, Nojin?
Yes.
Parsa, any issues?
No, sir, no issues.
All right, Nofal?
No
Alright.
issues.
All right. And if you guys can clearly see that if I put h as a positive number, if I increase it, you can clearly see on the graph, it is going to the other side. Like it's going to the x is equal to the negative side, to the negative quadrant. But if I put h as a negative number, you can clearly see that my graph is now moving towards the right, which is positive. So it behaves oppositely. Whereas if I move what you may call the value of k, like if I make it more positive, it moves into the positive y direction. But if I move it negative, it just goes down. Is this clear? So that is why your h and k inside an equation are going to be inside the completed form in your the values of h and k, which are going to be displayed using the completing the square technique of solving a quadratic equation, they are going to help you find out the coordinates of the turning point, which is the stationary point, minimum, maximum points, and all of that stuff. Is this clear? Any issues with this so far?
No.
Perfect. Well, yes. Apologies for that. I went a bit over time, but that's all right. Okay, guys, that sums up it for today. Apologies, Parsa, for letting you in late. I completely forgot that you did not have the link. Parsa, it's going to be the same link for every class. All right,
Okay.
I'll send it to you as well. Okay. And the timings are same as well, Noshin. You can even join us for a demo class on Saturday as well. Same time, same link.
All right.
All right. As always, we keep on saying. Also, Parsa, stay back. I want to talk to you.
Okay.
And everyone else. And keep smiling. Happy New Year, guys. Allah Hafiz.
I love this.
Allah Hafiz.
Yeah, sir.
Just remember. Let me. Yeah. Yes, Parsa. Oh, Parsa, when is our physics class? How many makeups do we have?
I can't remember. Honestly, I can't remember exactly. I think it's like maybe 2 or 3 makeups.
Yeah. All right. When can we take them? I'm available in the morning as well.
I don't know.
When are you available, Parsa?
Seems Friday I'm booked. So
What about
maybe
you?
we could do like um Saturday morning. Uh
When, Parsa?
like in the morning, maybe 12 p.m. Pakistan time, which would be 11 a.m. my time for 2 hours.
Yeah, we can do that too. On Saturday or something? I think I have a
Yeah.
class, but I don't really know if it's going to take place or not. Well, okay, I'll let you know. Okay.
Okay.
All right, all right, all right. Pasha, today is the first class of the crash course
Yeah.
for math. All right. When are you going to give your maths exam, Pasha?
In May,
Paper one and which other paper you're going to give?
I'm doing Pure 1 and Statistics 1.
You're giving stats. All right, all right.
I'm doing mechanics for next year.
That's perfectly all right. No worries. We'll accommodate you nonetheless in the other groups if we have. Okay.
Okay.
All right, Pasha. Keep smiling.
Thank you. You too. Take care.
Happy New Year.
Thank you.